Okay, one more type of graph to go over, bar charts. We're going to use the same data set as in the last exercise, guns. It's in the AER package if you skipped the one on line graphs. And so one of the columns in the guns data set is on laws. The command to create a bar chart is bar plot, but working with categorical data adds a little bit of a complication. Let me explain that a little. So rather than being numeric, the guns law is categorical and characters. It's no's and yeses. Let me just look at all of it. It is a series of yeses and nos for whether the state has a gun law in that year. And so R cannot sort of manually graph that in the same way because it doesn't know what the value of a yes or a no is intuitively. And if we just put this into the command bar plot to create a bar chart, it's going to tell us that it can't do that because it doesn't know how high the bar should be. It can't sort of automatically convert yeses and nos into something numeric. So what we want to do is we want to produce a table. And the table will just give us a count of the numbers of yeses and nos in the data. In total, across the 26 years in 50 states, there's 285 yeses for gun laws, there's 888 nos. And so by using table, we can produce a bar chart automatically. We don't have to do this as a separate step and save the output of the table. We can insert the table into the bar plot. By inserting the bar plot, the table into the bar plot, it knows that the height of the no's should be 888, the height of the yeses should be 285. And so that's sort of the basic bar plot. You can see how it sort of read the table. This table would be a little, it may be a little less informative because it's 26 years combined. And so we might want to take 1 year of the data and look at sort of the distribution of gun laws in that year. And so I'll create a new object, guns 1999, which is a subset using the year from 1999. And that bar plot looks a little bit more sort of representative of what we would expect, and a little bit different from all the years combined. So again, most of the customization features are the same as in plot or as in hist. All of these are sort of common. And so I'm going to change the colors, I'm going to add a title, and I'm going to adjust the y-axis because again, the y-axis doesn't reach above the total number of observations. What I'm also going to do here is add multiple colors. With a bar chart or with any graph, you can give it a list of colors. And when I give it 2 colors, it's going to apply the first color to the first bar and the second color to the second bar. So this can be a way to distinguish the data a little bit more clearly if you want.
So if you had, let's say, 3 bars and you gave it 2 colors, what would it do?
It would repeat the first one.
Okay.
So if I had 4 bars and I gave it 2 colors, I would get orange, blue, orange, blue.
Gotcha.
If I had 3, it would be orange, blue, orange. And so it'll repeat that list as far as it needs to.
Cool.
Okay, that's all I have to say about bar plots at this point. So I'll kick it back to you.
All right, I guess that means it's my turn. So share my screen here. I was following along. All right, so plot for the number of states with gun laws in 77. So does that mean I'm gonna need to, well, first, I want to pull Jake here. I gotta insert my code chunk, right?
Mm-hmm.
Then I need a new subset here, right? How did you do the subset again? I forget. Right. Okay. So guns 1977. Oops. And then let's see. I forget already. Subset guns year. Guns.
dollars. Oh no.
Oh, right. Guns and then year. 2 equal signs. Why do I need 2 equal signs again? Just because?
Because it's a logical operator, the 2 equal signs. If you're using 1 equal sign, it's saying like reset the value as this. That's not something you want to do in the command. You don't want to make year equal 1977. The 2 equal signs makes it logical, a logical operator if year equals this.
Gotcha.
And it won't let you reset the value of a year in the command. It'll just tell you that you've miswritten it.
Okay.
But instead of the arrow, you could use an equal sign on all of your commands. It just makes it a little less clear sometimes what you're doing.
Gotcha. Okay, so I've created this new object, right? And now, what did you do last time? Table, guns 1977. And then color, let's see, can we go like tomato 6? Is that a thing?
No, it only goes to tomato 4.
Only tomato 4. Let's see what tomato 3 looks like. Is banana 1 a color?
There is no banana.
No banana. Seems like there should be.
What even is the point of this program?
Light goldenrod is a nice pale yellow.
Well, I'm going with tomato 3. I already typed it out.
Okay.
All right.
It's got to have a different color for the other bar, so you can make golden.
Okay. Golden rod. Is that it?
Dark goldenrod 1.
Dark goldenrod 1.
But then it doesn't have to be like a list or something. You have to.
Right. Correct, Donnie.
Wait. So what did I do wrong here?
So see how it's got that C thing going on?
Yeah, that's right. That's right. And then are these in parentheses? Yes, they are. Like so?
So there's at least 2 things. So okay, go ahead. Finish your title.
Gun laws in 1977.
And then put that in
With
quotes.
parentheses, or quotes rather.
Yeah.
Unmatched opening bracket. Do I need to close it off?
Perfect. So in your table, you're just asking for a table of the entire data set.
Oh, right.
But you're plotting 1 column.
So, laws, is that right?
I think it's law.
Law. Oh, beautiful colors.
Gorgeous, in fact.
You know, you're right. Dark goldenrod 1 is a pretty sweet color.
There's so many good options.
It makes up a little bit for the lack of banana.
Well, you could probably add your own color. We can work on that in a future lesson, I suppose. There's a way to brew your own colors in R by manually specifying how much red, green, and blue you want.
Oh, wow.
So.
Is that R speak brewing colors?
No. Okay, that does it for this week. Thank you both again.
See you later.